Welcome, everybody. Welcome to the fifth episode already of the Getting Technical Live event. And today it's about tool selection, smart tool selection. Smart tool selection with an impact on machining that lasts, that is sustainable. And this is not new. People have since hundreds of thousands of years been selecting tools, trying to find the best possible tool for something they want to do. And I always compare a bit that when people have to select tools, it's very often like they have to buy a car. And they want to buy a car and they start the discussion on the tires. And then I think, already the tires, and you haven't yet selected the type of car, the branch of car, the engine, and you directly jump into the tires. Tool selection is a process where there are 5 very important steps we have to follow, and everybody has to participate in that process, and that's the subject of today. The 5 important steps in how to select in a smart way a cutting tool. My name is Patrick de Vos. I'm your host of today. And this event, of course, I do together with my colleagues, which are behind the scenes doing the magic, Alasia, Viju, and Olivier. They are the ones that makes this happening, that makes this possible. I'm just the one telling a little bit on cutting tools and stuff. And before we jump into tool selection, I want to give you the broader picture. As always, we talk about machining processes, which are physical processes we use to produce workpieces, and having insight in what is taking place here, understanding these processes, it's kind of like an equation. We refer to it as the machinability equation. And it's an equation in which there are quite a lot of variables, and there are some operations we can do with the variables. There are things we can do to connect variables, and machinability is about, in an intelligent way, in a smart way, combining all these variables in such a way that they lead to the wanted result. And evaluating that, because if you do things like that, after a while you ask yourself, of course, the question, did I do a good job? Well, for me, it's a very pragmatic type of answer I always give. Look at the tools. Tools will tell you how it was. Talk to the machining people. They will share their experience with the process, and those two things help you to refine this equation in such a way that it's becoming better and better every day. Today, the subject is tools, cutting tools, kind of the right side of the equation. The cutting tool and the different features of a cutting tool and how do they influence this type of thing. That's what we are going to talk about today. And before we jump in, for today, I want to give you still a slightly broader perspective on machining, because machining is a process. It's a manufacturing process. We use it to produce workpieces. And if we look to the situation of today in manufacturing, in a machining workshop, very typical is that people produce small batches of bespoke workpieces. And in such a situation, talking about the company KPIs, the overall company KPIs, if we look to the broader picture, it's about cost, it's about time, it's about quality, it's about total output, total turnover, it's about being sustainable in whatever way defined. And a company manager is confronted with this, and he has elements he can work with to achieve the KPIs as he has them for his company. And machining is one of those things, those tools he has to make sure that in his company he manages to achieve whatever KPI is prioritized. And into that machining, the element tool selection is what we talk about today. Intelligent tool selection. So machining can be applied in a sustainable way It does what it's supposed to do from an economical perspective, from a company sustainability perspective, whatever. And if we talk about selecting tools, let's sketch first what we are talking about. If I take within Seco all the different products we have, and I start to combine those things and create cutting tools, and if I look to all the applications in which we can use all these different cutting tools, you know, in the end, I end up with over 41 million possible combinations of cutting tools, applications, workpiece materials that make sense. 41 million. So the availability of cutting tools is not the big thing here. It's finding the one you need in your application, finding the best possible one. That's the challenge here. And doing that, it means that there are some quite tough decisions ahead of us. And we'll see that here and there in this process, out of that very diverse panel of cutting tools, finding the one we are going to use for the application will mean that now and then we will have to find compromises. And that's what I refer to here with the tough decisions ahead. And it starts phase one. I said, in my world, there are 5 steps to take. The first step is that we have to make sure that whatever tooling we select, it is in line with the company KPIs. You remember a couple of minutes ago, I said the big company KPIs, that's when we talk about the costs and the productivity and the quality and the total output and the sustainability. And in those things, in those KPIs, the company selects the one which are priority. And whatever follows there, and cutting tools is one of the things that follow then, must be chosen in such a way that it's in line with that level of decision. With other words, phase one in a company is to be done by management. And I sometimes refer to it, and I know some people, they think a little bit strange about it, but I always say that before you give tool selection in the hands of the machining people, management should make the first steps, should make the first decisions. And it's important because a company KPI can be productivity. Productivity meaning this is basically talking about time efficiency, do the best possible with the available time. Another KPI for a company can be more towards economy, the cost efficiency. Make as much as possible out of every euro you invest in your company. Another company KPI can be about quality. I as a company wants to have an image that quality is our thing, whatever it takes, whatever it costs, kind of. And the fourth one is about making sure that the company is flexible enough, is versatile enough in what it's capable of doing, so that the total output of the company is maximized. And if I try to translate this now a bit towards tooling, if productivity is your key thing, then you need cutting tools with the top performance. A little bit, and I put it black and white now, a little bit, whatever it costs, make sure you have top performing from a time perspective tools. If, however, economy, cost efficiency is your main driver, cutting tools need to be in line with that. Cutting tools need to be chosen so that the cost per cutting edge per tool life, per part is what you concentrate on. To the left is what we refer to as productive machining, high productivity machining. To the right is what we refer to as economical machining, kind of being aware of all the different cost factors and find the best possible tool to fulfill as much as possible that those cost factors are on a good level. If quality is important, if that is what drives you, then you need cutting tools with high precision. You know, the precision of a cutting tool you see reflected in the precision with which you can finish a workpiece. It's 1-to-1. But cutting edges also needs to be, from a technical perspective, sustainable. Sustainable in such a way that they keep their basic properties as long as possible. If, however, versatility is what you prefer as your main driver, then we have to look slightly different to cutting tools, because versatility means with as little as possible things, do as many as possible different other things. With other words, here we look for tools with, from an application perspective, have an as wide as possible application. Let me give you, because that versatility, for some people, it's a bit tricky. They don't really see what is meant with that. Let me say like this: if you have a milling job to do, and you recognize on a workpiece two applications, two operations. One is face milling, the other one is square shoulder milling. Well, if you do tool selection from, for instance, a high tool performance perspective, well, for the face milling operation, you select the face milling cutter, and for the square shoulder milling, or you select the square shoulder milling. And both are best in their domain, and so on and so forth. If, however, your wide application domain view on cutting tools is priority, because you look for versatility in your production, then perhaps we could ask the question, why not stay with a square shoulder milling cutter? Because with a square shoulder milling cutter, you can do face milling. So you can have one milling cutter for two applications. And if you start thinking in that way, that is when versatility is your driver. That's when you start looking for cutting tools with wide application domains. And of course, technical specialists would say, yeah, but wait a second. A square shoulder milling cutter is never as good as a dedicated face milling cutter for face milling. And that's absolutely right. And that is what I mean. Tough decisions need to be taken, because it's a compromise you have to find here. If you look a little bit, where should we use what? I would say the two on top here in the picture should be the two main options people have when it's about mass production, big batch production. While the two in the bottom is more what perhaps you should take into primary consideration when you are in a situation of a small batch production, especially of bespoke workpieces. This is the first step. And remember, this is a live event. If you have questions, put them in the chat, and in the end, we try to answer most of them as good as possible within the time we have available. Step 1, phase 1. What do I aim for on kind of management level when I do my basic tool selection? Phase 2, and this is the difficult one, prioritize. And this prioritization means choosing. And choosing means that afterwards you have something and something else you don't have. As I gave my example, square shoulder milling and face milling, if you leave it to technical specialists, they say, of course you need a face milling cutter for face milling, and of course you need a square shoulder milling for square shoulder milling, of course. But if people say, no, I think more in terms of versatility, that's another approach, and then perhaps you select a square shoulder milling cutter for both applications. What I see here very often is a bit of fight between, how should I word this now? People more programmers, planners, and people in the workshop. The ones that do basic selections, the one that use a tool, often it's a bit of a fight going on here. But these two first steps, what are your company KPIs? Which one do you prioritize? And what does that mean for your basic tooling? And phase two, dare to prioritize and take the consequences of whatever prioritization you do, are the two most difficult ones. And if these two are done well or not, I recognize quite easily. If I'm in a workshop and if I open a drawing in which there are cutting tools, and if this is what I see, I automatically think, okay, phase one and phase two has not been done properly in this case. And you know, each of these things you see, and of course, if you recognize this, that in your workshop, in some places perhaps it looks the same. Don't worry, it's all over the place a bit like this, unfortunately, because these things cost a lot of money, you know. But if I see this, then I think each and every tool on this photo once was labeled best selection. This is the one we need. This is the result of people that have to buy a car and they have discussions on the tires. Then it ends up like this. Phase one, phase two extremely important phases. Then we come to step three. Step three is okay. We know which company KPI we prioritize. Step two, we have the discussions needed to make sure that it's clear for everybody and that in our tool selection, we respect that prioritization. And we are aware of consequences. We know that whatever choice we make, it will not be perfect. There's always kind of a price to pay. Step three is taking this thinking from management, one could say, one step further into the organization. And one could say from management here, I end up in engineering, production engineering. And these are the people that have to sit down and say, okay, from a technical perspective, what properties of a tool do I have to prioritize now? So I'm in line with the expectations management has from the cutting tools in the company. And here it's about, okay, are we thinking in time efficiency, cost efficiency, quality, total output, whatever, what is important, and how do I judge tools? Should I think more in the application range of a tool? Should I think in terms of performance of a tool? Which performance then? Cost performance, time performance, whatever. Here we start to fill in the technical stuff. And after the big picture, after the big things, come in phase four, the technical details. The technical details like which cutting material, which coating, which geometry, which shipbreaker geometry, which way to clamp a tool. Should I go for insert systems or solids? Here is the technical details. Here is also where we really have to involve the technical specialists, because here the remarks are going to come about yes, but. The yes, buts come here. If I make this selection, it has as a consequence that something else will be in danger, perhaps. And the question is then, can we accept that? Because if not, we have to fiddle around here with technical details to come to an as good as possible compromise. This is work for specialists. This is where you need the people with the full insight, the really scientific insight, perhaps, in what's going to happen, How you remember the machinability equation? How are the things going to act? How are the things going to connect to each other? What's going to be the result? And so on and so forth. Phase 4. And phase 5, I take it, in my eyes, to the workshop. And here it's about the expert operator that have to do his part in this, and that is the cutting conditions. Now, of course, I'm pretty sure some of you will say, wait a second, cutting conditions, that has been selected already in engineering, in of course, and that was the tuning of it, but the fine-tuning, the taking care of the loose ends here or there, perhaps, that were overlooked in the selection process, that's what we do here. We tied everything together with cutting conditions. And really fine-tuning of cutting conditions, that needs to be done in reality. Because there are so many variables, I said, okay, you have the machinability equation and you have variables, but behind all those variables, there are sub-variables and stuff. So here it's phase 5. Phase 5 is, I take the selection as it has been made, hopefully taking into account all the previous things on a serious level. And then I confront it with the reality, I see what happens, and I make it work. I play with combinations of cutting conditions so that the tool functions, does what it is supposed to do. That's phase 5. That's the 5th step. With the 5th step comes the final check, kind of closing the loop. And I already said, in machining, I consider it from a pragmatic perspective. How do you know you did a good job? How do you know that every step led to the wanted result? Watch the tools. Watch the tools after they did the job. And if each step here was done with the needed accuracy, precision, also normally there should be a standardized thing you see in the end of a used tool. And if what you see is different from what you expected, that means somewhere you dropped something, somewhere you overlooked something, somewhere you forgot something. And that is closing the loop then. From here you go back to phase 1, 2, 3, 4, or 5, make the needed corrections, and continue. And closing the loop is making modifications. And here again, of course, we could say, okay, which type of modifications are we going to make? I believe strongly in closing the loop in the shortest way possible. And the shortest way possible is looking at the detailed features of a cutting tool, the cutting material, the carbide grade, the coating, the geometries, the nose radius, all that type of stuff. And that's what I try with an example to show you here. Depending on what you see in this final check, a machining expert will see a lack of. If you see something, that is an indication that the tool lacks wear resistance, for instance. And the moment you recognize that, then an expert knows what to do. He say, okay, if I lack wear resistance, I need more. And how do I achieve to have more wear resistance? And then you can start playing with geometries and materials and stuff like that. And that is what I try to show here in this diagram. It's kind of an indicator. If you recognize what you are missing in your tool and what you would like to have in your tool so it delivers up to expectations, where do you have to look for the solution? A solution is perhaps a big word. In what direction should you work to find an alternative tool that works better? If you look in the workshop, and I already showed you some photos, and you recognize some of it. Very often it looked like this. And each time I see this, then I think people have been spending fortunes on this. Why does it look like this? People have been buying cars and they had discussions on the tires, but they forgot to have a discussion on, why do I need a car? What am I going to do with the car? What purpose does the car serve? And once that is determined, only then you can have a detailed discussion on the tires of a car. But please don't stop start with having discussions on the tires. That comes in the end. It should look like this. Only a while ago, I was in a workshop in Belgium, and one of the operators, he was so proud, on his tools. And he said, look, these are my tools, and I know what to do, and I have been thinking on which tool I use for what, and I know what to do, and I recognize the tools, and so on and so forth. This is how tools should look in a workshop. And this comes, what is most important, people always say, in this selection process, if you have to prioritize, what is your priority one? What is the thing you value most for having correct tool selection? It's people. It's choosing is something that it's people who choose. And when we want to have a good selection, people need knowledge, people need experience, people need help, equipment, whatever, to make choices. People need to have the correct mindset. What do we really want here? Very short, too short. But we have the time which we have. Next time will be the next Getting Technical Live event is going to be much more interesting, because there I want to talk more in detail about evaluating cutting tools and the closing the loop thing I was just mentioning. Selecting tools is a company-wide activity. I mean, with that, everybody needs to be involved in this if you want to do a good job. And everything in the company relates to it. It starts with phase one. What are the company KPIs? And how do we translate them to the basic definition of how cutting tools should be? What they have to deliver, what their contribution is in the total picture. Management task, management job. Too important to leave in the hand of a technical specialist. He comes afterwards. He takes his part in. But first, it starts with management. Company KPIs, phase one. Phase two, the tough one, prioritize. Find the compromises. We select this and we are aware of that something else, and so on and so forth. Phase one, phase two, important. That's where the basic decisions should be taken. That's the first step. Step three, define in a technical way, translate in a technical way how a tool has to behave so it is in line with what was decided in phase one and phase two. This is the thinking about, should I do face milling with a square shoulder milling, or should I select the face milling cutter for the face milling operation? Well, knowing that means I have two cutting tools and so on. And it's technical translation. This is typical production engineering that should be involved. Programmers should be involved in this. After they did their job, we come to phase four. The details, the technical details, so important. Now we start to discuss about the tires of the car. Management decided we want to have a Formula One car. Nice, good. Then it's important somewhere along the road to have a serious discussion about which type of tires we are going to put on that car. This is work for specialists. This is about the cutting materials, the geometries, the coatings, the radiuses, the dimensions, all that type of stuff. Fill in as good as possible technical details, fill in as good as possible the tool features, so the tool, every individual tool, lives up to expectations. Phase 5, take all the loose threads which are all over the place perhaps, bind everything together, the cutting conditions. 2 steps in cutting conditions. You have, I make the comparison, it's tuning and fine tuning. Tuning is, okay, this basically should work. Fine tuning is, and this works best. Again, this is work for machining experts, for machining specialists, people who can really read the process, see what's going on, need where to twist and tweak a little bit. And don't forget to close the loop. Because it's important that the guy in the workshop knows why he's confronted with a certain tool, because there was a decision from management, but management better communicate to him why they decided that, so he knows what is expected. And if he gives feedback in the end that something is really wrong, he should feed that back to management and saying it was a very nice initiative, but we can't make it work. Close the loop, talk to each other. And make sure everybody understands everything. 5 steps for an intelligent or smart tool selection in such a way that it leads to a sustainable situation in the workshop, that things are in line with expectations, be it commercial expectations, technical expectations, marketing, customer relation, whatever, that things are in line, that you keep your promises. I hope in this very short time, at least I could give you the 5 big steps. Of course, out of every step, there are so many things we can continue further to talk about. And that is what for sure we will do somewhere in the future in the next episode in this series. Anyway, you can find all information you want also in other sources. We have the Seco technical books in which selection of tools and things are always a very important part. But let's see if there are questions. Let's concentrate a bit on which questions came in. One question is about maybe we need some correction factors to be calculated machine parameters to make the cutting edge life longer. Of course. That is. In the end, phase 4, phase 5, if I talk my own language, that is where people basically create their own correction factors. They say, okay, from the beginning, this was what we were expecting. And as I said, if you really put it, if you do the test against reality, you'll be confronted with all the little things that you can't take into the big equation. And there we start to work with correction factors. Correction factors in machining is for me a very important thing. It's every workshop should know his or correction factors, depending on the materials, the machines, the whatever. The next one is a good one. It's a classic. It's a classic. Shouldn't phase 4 come before phase 1? You remember the picture I showed you about the 2 guys arm wrestling? It's a question about this. Who drives and who follows? Personally, I say no. Phase 1 is priority. Phase 1 is about the total company. And, the reason of existence of a company is economical. People create a company with economical purposes. Nobody is creating a company because somebody likes to do machining. So no. Phase 1, if you buy a car, why are you going to use the car? What do you want to do with the car? And only then you start discussing which type of engine, which tires, and so on and so forth. I like this discussion because it's going really deep. It seems an easy question, but it's deep, you know. This thing, and tools cost a lot of money. Huh? Yeah, we better spend some attention to how to select them. The next question. Okay. Yeah, sorry. I always forget that. I use too many abbreviations, as some of my colleagues are always accusing me of. GTDA. GTDA is an abbreviation. It stands for Global Tool Deterioration Analysis. It's the final check I referred after step 5. You did all the things, you put the tools in action, and then you want to know, okay, is this good? Is this not good? Does it do what I... GTDA is an analytic approach we developed to do that final check, to see, okay, did the tools live up to expectations? And the approach is an analytical approach, which goes beyond the technological approach. It's an analytic tool to do the final check in the whole scenario of tool selections. Another classic. Is high performance and lowest cost in machining not the same? No. And let me give you a practical example. It depends, of course, on what do you mean with high performance and what do you mean with lowest cost? Let me start with cost. Which cost are you talking about? Is it the tool cost, the machining cost, the manufacturing cost, the operational cost? What cost are you talking about? It's very important for this question. And performance also is, what do you mean with performance? Is it number of finished workpieces per hour? Is it metal removal rate? How do you define the... But let's not... time is short. Let's not make things too complicated. Let's say performance is doing as much as possible in a given time frame. That we could call performance. And costs, as we talk about machining, let's call it machining costs. All the other things around it, we machining costs. Now, I answer the question by asking you a question. You have to select cutting speed. Step 5 in the process, find out cutting conditions. One of the cutting conditions is the cutting speed. Now, if you say high performance is for you most important, my advice, if you would ask me, I could tell you, use a cutting speeds of 20,000 meters per minute. Suppose now that the material you have to machine is titanium. Now, in theory, that's going to give you a very high productivity, isn't it? In theory. But the tool will wear out so fast that, one, you are going to spend a fortune on cutting tools. And two, if you look a little bit beyond the machining process now, the total time spending, you are going to have to change cutting tools so often that your machine will not even be running. The spindle will be stopped. You are changing tools all the time. So perhaps not a good idea if you say, okay, the other thing then, cost efficiency, machining, tools. I also have some advice for you. Use a cutting speed of 0 meters per minute. Trust me, I can't make it any cheaper for you. You don't even have to buy tools anymore. But you are not going to produce a lot of workpieces either. And I hope you understand what I try to say here. Performance in time performance and cost performance, and of course it depends of the definitions, but it's not the same. It could be close to each other, but it's not the same. And it's going to influence every individual of these 5 steps we talked about. So no, it's not the same. The next, we still have time for questions. With changing machining conditions, the age of the machine tool, the tool selection needs to be changed. Indeed. because if a machine machine tool is getting older, see accuracy, see performance, see available power, whatever, stability of the machine. Yes. I think in which phase this is work for specialists? This is work for machining specialists. I would say this is for phase 4 and 5. To some extent, of course, also management needs to be aware of that when machines are getting older, perhaps they have to modify their expectations a bit. So yes, there are side links involved in it, but for me, it's phase 4, phase 5. It's the technical specialist. If your machine is getting older, if the stability goes away, there's more risk for vibrations, but that's something a technician needs to take care of. I mean, compensate for that risk for more vibrations. And then the next question, but I don't understand the question. Dropping the cutting speed by 20% increases your tool life by 30 to 40. Yeah, indeed, that's the Taylor equation in machining, which is a subject we are going to talk about. That again, this is work for specialists. It's knowing, the consequences of what you do, because I say you change this, you change that, you change the carbide grade, you change the geometry, you change the nose radius, you change the cutting speed, you change the feed. One, you need to know why do you change this, and 2, you need to know what are the consequences of the change you do. Obviously. That type of relations are so important to have full insight when you are in the 4th or the 5th phase of a selection process. What is a sustainable cutting edge? People also refer to it as a stable cutting edge, but stable, then people think we are talking about vibrations and stuff like that. A stable cutting edge, a sustainable cutting edge, we mean with that a cutting edge that when you use a tool, the tool starts to wear out, and the wear becomes so big that after a while you have to change the tool, to replace the tool, regrind the tool. But in that deterioration process, the initial properties of a cutting edge, how should I express this now? There are differences in how long a cutting edge keeps its basic properties, the basic properties for which in the first place it was selected. If for instance, you go for accuracy, for precision, then the position and the shape of the cutting edge line is extremely important. And then the question is, how do I manage that even when a tool wears out, that I keep as long as possible the initial position and properties of the cutting edge line? And that is what we refer to as a sustainable cutting edge, a stable cutting edge. In the end, it will wear out anyway, but it's about how long can I use it and it still performs in line with expectations from the beginning. Questions continue to come in. Please put your questions also in the chat, and we can't continue forever here, but I do promise that afterwards I try as much as possible to answer the questions in the chat anyway. But okay, a last one. The question goes as follows: does the machining process must be influenced for the company's criteria instead of the performance? You need a diplomat to answer that question. I think the company criteria, the company goals always stand first. the people have targets with companies, and in a company they use processes to fulfill the targets, and one of the processes is the machining process. And this question basically for me is about knowledge, because once you have the target and you use real knowledge on machining, expertise on machining, and there are of course exceptions, but in most cases you will figure out a combination of a cutting tool and a cutting strategy and cutting processes and cutting conditions, so you fulfill as good as possible the company priorities. But this is perhaps this is one of the definitions we could give to machining knowledge. What is knowledge of machining? Knowledge of machining is being capable to master a machining process and all the elements in it in such a way it fulfills in an effective way. And I use the word effective on purpose here, not efficient, but effective, doing the job in an as effective way as possible. And now the last question, because I see time is flying. Sorry for the first answer. I can't give it more concrete. For me, it's about prioritization. It's about knowledge, and perhaps we can continue the discussion online here, whatever, because these are the important. I like this type of question. These questions are for me people that try to select a good car. And they do not discuss tires. They discuss the real things here. The last question. So with choosing additional process, except machining, we need to reach the... Okay, I think I understand the sentiment behind the question. And yeah, very correct. Machining is not an island. Machining is only one step in a production process. And before machining, there are other things. And after machining, this is somebody really thinking on the bigger picture. What can I do upfront machine? That's at least my interpretation. What can I do upfront or perhaps afterwards so that machining can be done in the best possible way, that it fulfills in the best possible way what it's expected to do. Yes, indeed. Once machining is machining, but seeing the broader picture is also so important. We have to stop here because I see already again over time. I see much more questions, but as I said, I take care of them afterwards. Selecting cutting tools in a smart way. Smart in it fulfills expectations, company-wide. Phase 1, what are the company KPIs and what does it mean for the broad thinking on cutting tools? Phase 2, prioritize. Be aware of you can't have everything. You will have to prioritize, and there will be consequences. That's how it is. Phase 3, where phase 1 and phase 2 is more management thinking, company-wide thinking. Phase 3 is more already the engineering people that have to step in. Okay, if I look from a technical perspective to cutting tools, the broad picture, how should I define technical performance of the tool so it is as much as possible in line with management expectations? Phase 4, the job for the specialists, fill in the details, the cutting materials, the geometry. Now we talk about the tires of the car. Eh? Now it's that type of stuff. And we all know in Formula 1, the selection of the tires can make the difference. So it's details, but they are crucial. Step 5, how do you drive the car? The cutting conditions. The pilot. How do you use it? The cutting conditions. And don't forget to check and make the loop back. Huh? If you don't win the Formula One race, okay, yeah, what happened? Where did it go wrong? Where do we need to improve next time? That's for me the loop back. Final check and closing the loop. Thank you very much. I hope you had an interesting half an hour and 15 minutes question and answer time. If there are more questions, put them in. I'll answer as good as possible. Next time, it's about tools wear out. And I said a couple of times now, if you know what to look for, you will learn a lot. So next time is about checking if what we talked about today, tool selection, if we did that correct. Looking forward to see you for the next time. Thank you.